All right, we are in Algebra 2. Today's lesson is 9-8, period of sinusoidal functions. Our date today is February 27th, 2020. Our objective is to do what, Sam?
Find the period of whatever that says, functions both from the graph and equation.
Yep, and it's sinusoidal. So sine and cosine waves. Sinusoidal. All right, so this is about the time that we hit in our class where we're kind of burdened by a lot of formulas, so just be warned that there's a lot of stuff to memorize, and I'm sorry, but that's the way it is. I'm going to try to simplify it, make it as crystal clear as possible, but I know I'm only going to get like 50% of you to give me like a 4 or higher. My goal is to get at least 70% of you a 4 or higher by the end of the lesson. All right, thank you, Sam. So our vocab, what is a period? Are we in sex ed? We are not. So in math class, the distance it takes to complete one cycle. And by cycle, I mean you go back to the same height. So if you don't like the word cycle, you can use the word, well, height is not quite true either, because if I go from here to here, that's not a cycle. If I went from here all the way back again up here, that's a cycle. So when I'm saying the word cycle, I really mean, hey, if I start here and I'm pointing up, then I come here, I'm not pointing up yet, and now I'm pointing back up. So from here to here is one cycle. And I'm going to write that down for you as well. Thank you for all of you that were already doing that. What I call a cycle, or I guess I should be calling it a period is this entire thing. That is one cycle or one period. And with sine waves and cosine waves, there are an infinite number of these periods, so we're always talking about a certain domain for our function. And it's very, very crucial to today's lesson, knowing the difference between a quarter period, a half period, a full period. How far are we moving in our sinusoidal function? So, are you guys ready? I'm going to quiz you.
Midnight.
So that you can say full period, half period, or quarter period. You get 3 choices. So everyone's going to shout this one out. Ready?
Half.
Quarter.
Come on, Brian. Keep trying.
Quarter. Half.
Oh, I guess I can do this one too. They won't ever do this to you.
3/4.
3/4. What about? I don't hear Leo's voice. Leo, you do this one. If the whole thing is 4 pieces, 1, 2, 3, 4, and I'm doing one of those fourths. Quarter. I didn't hear Cheyenne. She wasn't speaking loud enough. Cheyenne, do this one. Are there any questions on if you're a half period, quarter period for our function? No? No questions?
It'll fit it.
All right, so this is not the best example either because you can have a sine wave that goes on forever and ever. But one period is like a full rotation through the sine wave. So if I start at one point and I'm going up to the top right, where's the next part where I'm at this height and going to the top right? Now I'm going bottom right and going top right. So between here and here is one full period. If I don't make it the full period, I can go half of the period, or I can go a quarter of the period. But in terms of each of these segments, I'll either be giving you a half, a quarter, or a full period. So this is one of the 4 pieces. 1 out of 4 is a quarter. So I'll write it down for us as well. Just have it for the static notes as well. I know some of us don't look at the video. So this right here is 1/4 of a period. This right here is a half of the period. I can do another type of a half. This right here is also a half of the period. But the full thing is a full cycle. All right. So you'll be getting questions on the Khan Academy that say, what is the period of this function? You'll say it's 5 or it's 3.6. How do you come up with that number? And here it is. And I'll type it because it will make my notes look neat. To find the period of a sinusoidal function, you are going to multiply. Let me change my color here. You are going to multiply the distance that they give you. So they'll give you, hey, the distance between here and here is 3.2. You multiply the distance in terms of the x distance by the reciprocal of the fraction of the period. I'll zoom in so that people can see from the back. Again, you multiply the distance, the x distance, by the reciprocal of the fraction of the period. For example, and I'll do examples down here as well. Let's just arbitrarily say, I don't know, the distance here is 2. I'm just making that up. If the distance here is 2, what's the period? Well, I haven't gone the full period, so I need to multiply by another 1, 2, 3, 4. I need to multiply by 4. 2 times 4 is 8. So the whole period is 8 if this distance is 2. How did I get 8? Well, the reciprocal of 1/4 is 4 over 1. 4 over 1 times that 2 is 8. So if I have a half, and I know that that length is, I don't know, 3, the reciprocal of a half is 2. 2 times 3 is 6. So if this distance is 6, if this distance is 3, the whole period must be 6. You'll be seeing that over and over again, well, at least 2 times, with the following 2 examples. So these are very, very similar to what you have on Khan Academy. This is example number 1. We have a trig function. Zoom out just a tad. There it is. And I wrote it big up here, but it's also down here graphically. We have this point, negative 1.8, 2.2. Another point down here, 1.2, 0.2. And I'm asking, what's the period? I need the exact answer. You can't say, it's about 2-ish. No, I need like the exact decimal answer. So the first question I ask is, well, what is a full period look like on this graph? And this is where you need to start annotating this graph. If I start, I'm just saying I start here. I could have started here. I could have started here. Let's just randomly say I'm going to start here. Where does that full period end? Is this a full period? Is that a full period? Where is a full period? Go ahead and mark it on your notes. What is a full period? And hopefully what you're seeing is that a whole period looks like this. And I can make that slightly better. That's one period. Because I went from a max to a min and then back to the same max. Or if I go from a minimum to a minimum, that's a full period. This is a great point where you can ask me, hey, how did you get that? How did you get one period? Why isn't that like half a period? Yes?
Is it the same either direction?
Either direction, yeah. So I could have come this max over here. That's also one full period, exactly.
Okay.
Or I could have done from here to here. That's a full period. As long as you're at the same height, one full cycle, that is one full period. All right, so therefore, the points that it's giving us, it's talking about this distance right here. I need to ask you guys, what fraction of the period is that? Is that a quarter? Is it a half? Is it a full? With the choir raise hand, who can tell me? Ellery? It's a half. So they gave us a half of the period, and we need to multiply the distance that it's giving us in terms of the x distance, this negative 1.8 to 1.2. The distance between those two multiplied by the reciprocal of that fraction. And that's a very formulaic way of doing it. If you just think about it in terms of like logic, I'm like, I know that this distance is blank or whatever. We'll figure that out in a sec. And I need to multiply that by 2 because, look, that's half. And I need to multiply it by 2 because that would be the full thing. If you just multiply by 2 that way and you don't have to worry about reciprocal of the fraction of the period, that's fine. That's more logical. I like that way better. I'm just doing kind of the cold brute force method of, hey, find the fraction, take the reciprocal, it will always be that over and over if you like that formula. Okay, so the question now is, what is this distance, the x distance? How far is it from here to here? What is that distance? And notice I'm not going like this, not the y direction, the x direction. So the x coordinates, I'm going to do 1.2 minus negative 1.8. So write it off to the side. To find this change in x, I'm going to annotate it delta x, I guess. Delta x is going to be 1.2 minus the other one, negative 1.8. Question, Ellery.
Does it matter if it's 1.2 minus negative 1.8 or 1.8 minus 1.2?
Either way is fine, yeah. I just need to find the distance between them. Know that your answer will always be positive. Question, Leo.
Why is it a triangle?
Triangle, I read that as delta or change in. So I'll write off to the notes here. I read this as delta, if you're reading it to me. And what it means change in. And I always tell the story whenever I talk about this shape that the first person that taught me this Greek letter should have been my math teacher, but it was my English teacher. She would write off to the side, delta your sentence structure, or delta this word, use a synonym, or something like that. She would tell me what to change in my paper. So delta means change for us as well. Should have been my math teacher. All right, so the change in x, delta x is this distance. And again, when I have two negatives, that's going to turn into a positive. So I have 1.2 plus 1.8. And 0.2 and 0.8 is a full 1. So 1 plus 1 plus 1, there's 3 of those, so the answer is 3. The total distance here, the change in x that I was trying to find is 3. Again, what does that mean in the context of the problem? This distance right here is 3. 1, 2, 3. Distance of 3. Now, how far is the full period? Can anyone tell me what it is and how they got that? Beverly?
6.
How'd you get 6? It's correct.
Because that half is 3. And it's like that. The one we just solved for is 3.
Yep.
And then to get to the other side, would be the same distance. So you just add 3 and 3.
Add it again. Okay, perfect. Did anyone solve it a different way? You're all using logic. Awesome. That's kind of what I was hoping, and you guys did it. Okay, so yeah, the answer is 6. So we will say, oh yeah, question, Lorena?
Is it always just double what you got from adding the...
Unfortunately, it's not always double. Sometimes we'll have to multiply by 4, and sometimes we won't have to do anything at all. It depends on how much of the period it's originally giving us. Sometimes they give us a quarter. Sometimes they'll give us a full period. Sometimes they'll give us half like that. So the period is 6. Done. Box it. Again, the formulaic way of doing it, for those of you that are, I guess, watching the video, because everyone in here seems to have the logic down. If I take the reciprocal of 2 over 1, reciprocal just means flip the top and the bottom. It's now 2. 2 times 3 is 6. That's what I meant by multiply the reciprocal of the fraction by this length. Okay, let's try another one. All right, so here's your trig function. I told you what these coordinates are. They're listed down here as well. So, first, draw an entire full period. You can say, okay, the period between here and somewhere that way, or between here and somewhere that way. What does a full period look like on this function, starting from at least one of these points? What is a full period? So hopefully, you saw that the full period looks like either this, between those 2 points. Oh wait, whoa, 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 whoa. Between those 2 points, sorry about that. Or you could have done between these 2 points. That is a full period. Because again, you're checking, I'm cycling, I'm going down and to the right. Where's the next time I'm going down to the right with the same height? Right there. So that's a full period. We'll label that 1 period. Therefore, the thing that we're trying to find, again, is the same fraction. It's 1/2, half of that period. All right. Our next step, we need to find the change in x. How far do we move from the left to the right, or from the right to the left? It doesn't really matter, as long as it's a positive distance. What is the distance between those 2 points? And I can zoom out just too much. So you can see the coordinates in the top left. So I'm looking at pi over 2 to 5 pi over 4. How far did I get, or how far did I move to get from here to here, or from here to here? It's a subtraction problem. Oh, they have not the same denominator. If you don't have like denominators, you need to make like denominators. I'll help you guys out. Here we go. Again, circle these coordinates. We only care about the x's. The y's don't affect us that much. So I'm just going to kind of randomly say the second point minus the first point. You could have done it the other way around. So I'm going to say this is going to be 5 pi over 4 minus pi over 2. That's the change in the distance. You will always, 100% of the time, just subtract them. That will be the delta x, the change in x. Okay, these are not like denominators, so what am I going to have to do? Quiet, raise hand. Help me out. India.
I'm gonna have to make like denominators, and you can multiply pi over 2 by 2 on the denominator and get 2 pi over 4.
All right, I'm going to write down what you just said. So that's 5 pi over 4 minus 2 pi over 4. All right, and next, what is our final delta x? Who's got this? What's 5 pi minus 2 pi? If I have 5 apples and I take 2 apples away, how many of those apples do I have? Yes, Ellery. 3 pi over 4. So our total distance in terms of our x between those 2 points, 3 pi over 4. That's not the answer. We're about to write down our answer right now. Period is blank. What is that blank answer? I'm glad we can be mature. All right, so 3 pi over 4. What do I do with this? That represented half of the period. Close. You only multiply the numerator, not the denominator. And next time it should be a quiet raise hand. But all right, so it's going to be 6 pi over 4. All we have to do is double it. So this is going to turn from a 3 pi to a 6 pi. 6 pi over 4. And that can be reduced to what? With a quiet raised hand. Someone reduce this? Yes, Leo. Divide the top and bottom by the greatest common factor.
2.
And then you get 6 divided by 2 is 3 pi over 2. There it is. Box it. Thank you, Leo. And thank you everyone else that helped me out. That's one type of problem, and then there's a second type of problem. Remember, our objective today had 2 pieces. Our objective said both from a graph and an equation. We've been working purely with graphs. Now we're working with equations.
Are these shorter?
These are, they're a little bit easier. It's pretty straightforward. Graphs is a little bit harder because you have to interpret. All right, so here is your formula. You know what A and K do. We did that last lesson. A affected the quiet raised hand. Someone new, hopefully. Look back at your notes. Come on. 9-7. What do we do? What was A and what was K? Someone new. Beverly, did you have your card in already? Sorry, I can't call on you. Brian. A is for amplitude. Thank you. I'll take your card. I'm just filling in what we already know before I tell you the new stuff. What about K? We know K as well. What is K? Jay Burns.
The midline.
Midline. Thank you. And now we're adding one more thing into the mix. We'll do another one later, which is B. We know what B is going to do now. B is going to affect the period. It isn't the period because we have to do some stuff to it, but it affects the period. While K is the midline, A is the amplitude, as long as they're positive, right? B is the period. So, here's your formula. It's one formula, you memorize it, you're done. The formula is a full rotation. In radians, a full rotation is 2 pi. In degrees, a full rotation is 360 degrees. I want you guys to get used to radians. That's what it's going to be on Khan Academy as well. A full rotation is 2 pi, and then we have to divide it by whatever that variable is. So the full formula is the period is equal to 2 pi divided by B. But there's a problem. This has to always be positive. Boink. Now it's always positive. Make that B absolute value. The period is always positive. Write it down. The period is always positive. And we have that in our formula by having the absolute value of B. Just one formula, 2 pi divided by whatever that letter is, and you're done. All right, 3 more examples, 3, 4, and 5, and we're done with the notes. So, from an equation, ignore everything that we don't care about. We don't care about this -2. We don't care about that +2. We don't care about the fact that it's sine, really. We only care about the fact that there's a 3 pi in front of that x. All right, so I'm going to come over here and rewrite my formula. P is equal to something, something. Who can fill in the formula? Period is equal to what? Anna.
2 pi absolute value b.
Over absolute value b. And what is the absolute value? What is b?
It affects the period.
It affects the period. And then our formula up here says b is that number, the thing in front of the x. What is the thing in front of the x in this case? 3 pi, exactly. Okay, well, 3 pi is already positive, so don't worry about the absolute value. And what's, with another quiet raised hand, someone new, what's 2 pi divided by 3 pi? Cross out things that are the same. Yes, Chewy, go.
I don't know.
What's, well, I see a pi on the top, pi on the bottom. What am I going to do with that?
What?
What's pi divided by pi?
Pi?
It is not pi. 1,000 divided by 1,000 is 1. Ah, so that's 1. So they cross cancel. They're gone because 1 times 2 is 2. 3 times 1 is 1 or 3. And then the answer, therefore, Chewy, is what?
Oh, sorry.
What are we left with?
For what?
Just rewrite what you have left.
2/3.
2/3. Done. The period is 2/3. It's that easy. Let's try another one. Rewrite the formula. P is equal to blank over blank. Something over something. I'll give you the fraction symbol. Quiet raised hand. What is it? Period is... I want to get more participation in here. Emily. There it is. Yeah, thank you. All right, we have to do a little bit of math here because we have fractions and fractions, embedded fractions. So really what I have here is I'm saying 2 pi divided by 3/4. That's the same thing, right? I'm just changing this fraction symbol into a divide symbol. Oh, well, check this out. I see a fraction on the right, so let's make a fraction on the left. Anyone remember this rule? Shout it out. Shout it out. Shout it out. Louder.
Keep it, change it, flip it.
Yay! All right, so 2 pi over 1. I kept it. I changed it. I flipped it. And someone tell me what my final answer is. I'm basically done after this step. I just multiply the tops, multiply the bottoms. Sorry, Ellery. I want to call on you. I need to get other people in here. Yes, Cheyenne. Multiply the tops, yep. 8, yep. Done, box it. There's our period, 8 pi over 3. And our third and final example, I guess it's technically example 5, but third of these equation types, what is the period of that guy? All right, someone, quiet raised hand. P, our period is equal to what over what? Has everyone got in yet? Sorry, Atziri, you're up now. Yep, 2 pi over... over 3, like that. You're really, really, really close. Something about that negative. It's going to be a positive. Well, yeah. And you don't have to answer right. It's the absolute value. Excuse me. Yep. Okay, so we're going to solve this the same way. This is 2 pi divided now by pi over 3. Keep it, change it, flip it. It's 2 pi over 1 times. So I kept it. I changed it. I flipped it. Our last volunteer for the day. I think we have everyone in now. Ellery, you've been waiting very patiently.
6 pi over pi.
Yep, 6 pi over pi, which turns into?
So that would be just 6.
Just 6. Thank you. There it is. Box it. So equations are a little bit more straightforward. It's the same thing over and over again. The worst thing that's going to happen to you is a keep it, change it, flip it. The graphs are a little bit harder to interpret. How well can you do the objective? How well can you find the period of sinusoidal functions from both a graph and an equation? Try to get at least 70% of you 4s or above. 3, 4, 3, 5, 4, 3, 3, 5, 3, 4, 3, and 3. Darn, I think I only got roughly 30% of you 4 or above. It's a hard lesson though. I'll do better next time. Cool, that concludes the notes.